Hello friends, welcome to this LeetCode 349 daily problem. So in this, which is minimum operation to make array element 0. In this problem, we have given 2D array queries where each queries of L is of the form L, R. L and R are inclusive. uh, we need to perform some number of operations, and in one operation we can select two integers a and b from the array, and then we can replace it with then floor of a by 4 and then floor of b by 4. What we need to return, we need to return the minimum number of operations required to reduce all the elements of the array to 0 for each query. Let's understand this problem again with the example. So as you see in the example 1, we have queries array like this. So we basically have two queries here, 1, 2 and 2, 4. 1, 2 means we have the array from numbers 1 to 2, which is 1, 2, and then in another query we have arrays from 2 to 4, which is 2, 3, 4. In one operations, we can select two integers, any two integers, and then we can replace it by dividing it by 4, right? Floor of a by floor and floor of b by 4. So here we will just select 1 and 2. We will divide it by 4, and our array will become 0, 0. So how many operations we needed here? Only one. For the second array, we will select 2 and 4 first. So our array will become 0, 3, 1. Again, we will select 1 and 2. So our array will become 0, 0, 0. So how many operations we required here is 2. So our answer will be 1 plus 2, which is 3. Right, now let's understand how we are going to solve this. So one thing we first need to understand here is when we say divide floor of a by floor and floor of b by 4. So what does it mean? So when we will divide it by 2, we will shift one bit to right? Now here when we are dividing it by 4, we will need to shift 2 bits position to right? Let's take it by example. So we have 5 like this. When we will divide it by 2, we shift it to one position, right? And it will be become like 0, 1, 1. Sorry, 0, 1, 0, which is equivalent to 2, right? When we will divide it by 4, we will shift 2 bits. So it will become like 0, 0, 1, which is 1, right? Now, the number of operations that I need to make this 5 as 0 is equivalent to the total number of times I need to shift this 2 bits, right? So it basically has 3 bits, right? So how many number of operations that I will need? It's total bits plus 1 by 2. Operation needed to make number to 0 by shifting 2 bits. By this operation will be equals to total bits plus 1 by 2, right? This we understand, right? Here we have 3 bits, so we will need 3 plus 1 by 2, which is 2 operation, right? Now we will have the integer array, which is in between, which have the number from 1 L to R. We can reduce this problem to integer array from 1 to R minus total number of operations that we will require from 1 to L minus 1, right? So total number of operations that we will require from 1 to R minus total number of operations that we will need from 1 to L minus 1. Now, how many operations we will need to make this 1 to R as 0? We know if we want to make one element to 0, we will need this total bits plus 1 by 2, right? So we can calculate how many operations that we will need for each digit, right? We will calculate like for 1, for 2, and so on until R. So total number of operations will be sum of operations for each digit, sum of operations from 1 to r, right? Minus sum of operations from 1 to l minus 1. So this is for the each digit we needed, right? Now we can select two integers in one operation, right? So if we can select two operations in in one time, sorry, two digits in one time, then we just need to simply divide it by two, and this will be our answer, right? See, in one, so for to make this one element is zero, we will need this particular of operations. Let's suppose we will have the solve method, right? Which will return us this. To make, sorry, not there, not here. So we know that okay, for one element we will need this particular operations to make it as zero, right? So the number of minimum operations that we will need here is how, like for each digit, I will calculate the number of operations that are required from 1 to r. Again, I will calculate from 1 to l minus 1, and then I will just simply divide it by 2, because in one operation I can select two numbers, right? Let's try to code it. You will understand it more. So we will just declare our result value as 0 here. We will go through each query, and then we will have here one solve method which will return us the total number of operations that we required from 1 to r. So it will take only one value, which is int num. Okay, our result will be for each query we will first calculate the sum of operations. So solve for r, so which is query of 0, query of 1, minus solve of query of 0 minus 1, which is l minus 1 plus 1 by 2. Now let's see how we will return this total number sum of operations from 1 to 1. One way is we will go through each number from 1 to num, and then we will see how many bits it has, and then we will do plus 1 by 2 for each bit. But then it will increase our complexity. What we can do is, we know that if we have the number from, let's suppose, 1 to 8, right? So we know that okay, this has a, first we will calculate how many operations that will be required one by one. Okay, so first let's suppose our base is, we are at from 1 to each number will have at least one bits here, right? So let's suppose our bit right now is set to 1. So how many numbers here will have bit 1? Total 8 bits, total 8 numbers we have, right? Now we will go to the fourth, we will again multiply it by 4. So how many number now have 4 bits? We will at least 2 bits, right? So a total bits plus 1 by 2, right? So first we will see how many numbers have 1 bit, which is 8. Now how many numbers will have at least 2 bits? Sorry, first we will see, we are dividing it by 4, right? So we will first see how many numbers have 2 bits. So like all we will start with 1. Sorry, just confused here. Yeah. So how many bit we have from one? So we start from one. So we have one bits for all these elements, right? So eight. Now we shift to all these bits in one operation. We shift all these bits by two bits into the right position, right? So now we will see how many bits we there are with two bits, right? So how many have the two bits? Sorry, we shift it by two. So one, then again we will see the fourth number, four, right? Which is basically three bits. Now we need it. See, in one operation we can shift two bits. So we start with one. Now we will see how many have at least three bits. So how many will have three bits? This from 4 to 8. So which is 5 elements. See, we are dividing it by 4, right? So we are shifting 2 bits. So we start with the first bit. We will see how many elements have 1 bit. All the elements have it. Right now again 2 bits we shift, right? So we will see how many elements have 3 bits. There are only 5 elements. Now we will see how many elements have 5 bits. Do we have actually any number with the 5 bits? No. So we will stop it here, right? So how many operations we will need, which is here, the total number of bits plus 1 by 2, right? How many operations we needed? 8 plus 5, which is equals to 13, right? So this way we can solve it. So what we will do, we will just introduce one. We will first, let's suppose this is what we need to return. Total is equals to our 0, right? We will have bit position as 1, right? We will just, which we will just increment it by 2, make it as 1 int only, or and also the mask value, right? So 1 bit, like what is the value starting point, we will have the mask as 1 only, right? So while mask is less than equals to none, right? Our in our total, what we will do, we will just do, इसको फिर मास से ही हम कैलकुलेट कर लेंगे. So total plus is equals to how many numbers that we have is from mass to num, right? So bit is 1 is basically mask as 1, then mask as bit as 3 means mask as 4, bit as 5 means mask as 16, right? So we will see how many numbers are from 1 to 8, then from 4 to 8, and then from 16, right? So total plus is equals to number minus mask plus 1. So let's do it as 1 LL, so that it will return it as long, and this only we need to return here. So this will be our answer. It will return us the total number of operations, right? For 1 to R, it will return as from 1 to L minus 1, and then we will just divide it by 2, because in one operation we can select two numbers, right? So we just simply return the result here. Let's try to run the test cases now. Oh, we didn't increment the mask. Let's do it by 4. We will increment 2 bits, so we will just multiply it by 4. Okay, now let's try to submit this. Cool. Right, so this is how we just solve this problem. If you don't understand it, I would urge you to go through this video again and try to solve it by yourself. Once you will try, you will get through this idea of it. Okay, I hope you like this video. Thanks.